Hello everyone, and welcome to the Mat 211 review on systems of linear equations. My name is Julia, and I am a tutor for the tutoring centers at ASU. So for our example problem this time, we want to solve the following system algebraically. We want to express our answer as an ordered pair, xy. If there's no solution, we'll enter no solution. And if the system is dependent, we're going to express our answer in terms of x. And this means that we'll have some function y equals some function of x. So for instance, we could have y equals 5x or y equals 5x plus 10, something like that. But everything on this side will be in terms of x. And we're going to go ahead and show all of our work. So we have these two equations, 3x plus 4y equals 10, and x plus 4 over 3y equals 10 over 3. So there's a couple different ways we could go about finding our solution set for this system of equations. We're going to use elimination today. Elimination means that we are adding some multiple of the equations together to get rid of one of the variables. So we look at our two equations here, and what we want to do is we want to add these together or subtract one from the other such that one of either x or y goes away. So we need either x or y to be the same multiple on both sides. So we would either want like a 3x here, or we'd want this 3 to go away here, or something like that. And then we'd have to do whatever we did to that x to the rest of the equation as well. So let's take a look at our second equation because it's got fractions, and fractions can kind of be a pain to work with when we're doing this. So let's go ahead and start by getting rid of the fractions. So we have x plus 4 over 3y equals 10 over 3. And we see that we have a 3 on the bottom here in the denominator in both of these. So if we multiply the whole equation by 3, then we can get rid of that 3. So when I say multiply the whole equation by 3, this is not the best notation. Instead, what we're going to say is that we have 3 times the left side, which is x plus 4 over 3y. And that's going to equal 3 times the right side, which is 10 over 3. Okay, great. So if we distribute this 3 to both sides, we have 3 times x plus, we have 3 times 4 over 3, so you can just write that out, times 4 over 3 times y. And that's going to equal 3 times 10 over 3 on this side. So we can see that the 3's here are going to cancel out. So this and the 3's on this side are also going to cancel out. So that leaves us with 3x plus y, plus 4y, plus 4y equals 10. Now this should be looking familiar to us at this point because it's exactly our first equation. So what that means is that our second equation is a multiple of our first equation. And what we're going to end up with is that our solution set is dependent, meaning that we have infinite solutions. So let's see why this is true. So if we have, this equation, we've now rewritten it as 3x plus 4y equals 10. So if we subtract these two, 3x plus 4y equals 10 minus 3x plus 4y equals 10. So remember, if we minus this, then this is same thing as saying 3x plus 4y equals 10 plus negative 3x minus 4y equals negative 10, right? So we're just treating this minus here like it's a -1, and we can just multiply that across. So that means that if we add these two together, we have 3x plus negative 3x, that's 0. Then we have 4y plus negative 4y, that equals 0. And then 10 plus negative 10, which is also equal to 0. So we have 0 equals 0. So how do we interpret this? So whenever we see that 0 equals 0, this is always true. So it doesn't matter what xy pair we pick. The equations will always both be true. And so what that means is that for any xy pair, we have solutions for each of these. So that means that these two share infinite solutions. And we can think of this as meaning that they run along exactly the same line in xy space. So you could go ahead and graph this on your calculator to prove this to yourself. We could also look at it as if we solve for y in either of these, we will end up with the same function in terms of x. So let's go ahead and erase this a little bit, make ourselves some space here. Get rid of that. So if we have our top equation here, we have 3x plus 4y equals 10. If we solve for this in terms of y, we'll first subtract 3x from both sides. That gives us 4y equals 10 minus 3x. And then if we divide both sides by 4, we end up with y equals, and let's go ahead and distribute this 4 across our subtraction here. So that would be 10 over 4 minus 3 over 4x. So that's for our first equation. Now let's look at our second equation. We have x plus 4 over 3y equals 10 over 3. So again, we can subtract the x from both sides. That gives us 4 over 3y equals 10 over 3 minus x. Now, in order to get rid of this 4 over 3, remember that whenever we have a fraction, we can multiply it by its reciprocal, so 3 over 4. And that means that we have 12 over 12, which equals 1. So we'll go ahead and multiply both sides of this equation by 3 over 4. So we have 3 over 4 times 4 over 3 on this side times y equals 3 over 4 times 10 over 3 minus x. Now, so we know that these will, go to 1. So, and then on this side, we have, if we multiply the 3 over 4 times 10 over 3, we'll get rid of this 3 here and this 3 here, they'll cancel out. So we would have, if we just look at that directly, it's 3 over 4 times 10 over 3. Those go away. So really this is going to be 10 over 4. It's a 4 there. And then we would have 3 over 4 times negative x, so that, or minus x. So 3 over 4x, which is the same equation as we found before. So we can express our solution, our answer, in terms of this equation, y equals 10 over 4 minus 3 over 4x. So great. Clear those away. Before I go, I just wanted to remind you all about our tutoring services at ASU. So for additional tutoring services or academic support at ASU, you can visit the link tutoring.asu.edu and use the tutor search function to find tutoring services for your course. This link here that we have will take you right to that function or that tool. So thank you so much and have a great rest of your day.